Okay, so remember, caveat, let it wash over you. We're going to see lots of bugs and stuff today. I'm talking about the Mothbox. That's this thing. What is a Mothbox? It's a big, bright light. It attracts bugs. It takes photos of them. It tries to figure out what kind of bugs there are. There's more than one kind of bug. Did you know that? Lots of bugs. I'll talk more about that later. The coolest part, you can build this whole thing yourself. A little bit of background, who we are. It's not just me. This is also Bree Johns, Kit Quitmeyer, and Hubert Stigl. Hubert loves bugs. Kit is an awesome, badass textile artist and head of our manufacturing. Bree Johns is the former Gosh community manager. You probably all know Gosh. I'll talk more about Gosh later. But who's this guy? This is Andy. I make weird things. I like helping people. I've been sued for millions of dollars by sex toy companies, a sex toy patent troll. I got tricked into doing a stupid survival TV show that didn't really make much sense, but we're going to keep going. Right now, what do? I hang out with small capybaras and tapirs, and also my partner, and we live in the jungle in a place called Digital Naturalism Laboratories, where we do art and technology for interacting with nature. And we try to do this as much as possible in the wild, in non-human controlled places. And the place we have our base is in Panama. You might know it because there's a canal that cuts the continents in half. On each side of that canal is amazing, cool, awesome jungle. And so I live in an abandoned canal town called Gamboa that's full of scientists from the Smithsonian. And we set up our own weird punk lab next to the Smithsonian where we build tools. And so it's a little solar powered prototyping workshop. We got laser cutters, 3D printers. We even do our own recycling and make cool goos and all kinds of fun stuff, even 3D print with garbage we get. And we run a lot of art science events. We teach field courses, design courses. This was actually a design course at the Glasgow School of Arts. This is my second time in Scotland. First time in May and not January. It's great. And another thing I do is I help run a bunch of conferences, like the Digital Naturalism Conference that we had in Thailand, Panama, Sri Lanka, Indonesia coming up in a month, in 2 weeks. Who's a dinosaur here? Give me a little shout out. Woo! We got lots of cool dinosaurs. Awesome. And you have 3/4 of the people organizing this event here at Open Hardware Summit. So yeah, Lee and Sid, woo! I also help organize things for the Gathering for Open Science Hardware, or GOSH. We had GOSH 2022 in Panama. There's one in Shenzhen. There was one in Chile. All kinds of cool places. But kind of the key thread here is I like to work with field biologists, engineers, artists, and I try to get them all to figure out how to interact with nature in new kinds of ways. This was Michael Candy, awesome robot artist, built this tree climbing robot in Thailand with us. This is tools for animal enrichment. This is one of our clients, a red panda. There's a sun bear client, a tapir client. So even ant clients. I got started making computer vision for seeing when Sally the ant's talking to Susie the ant, and for how long. And I've done camera traps that we hack really cheap so we can make them nearsighted so they can see bugs, and you can put little fiducials on bugs. 360-degree camera traps, so you're not limited to a biased point of view. You can see oh, it's not one agouti, that's actually 4 agoutis hanging around there. Butterfly strength testing machines. This is a floating fishing bat camera that's on a gimbal, and it has to be disguised like trash so that people don't steal them. And importantly, everything we do at Dynalab, everything I do in general is open source. And because if it's not open and you're using it to do science, you're not actually doing science. And so that's very important. And so one of the cool things that we're doing right now is this project called the Mothbox. I realize I'm barely talking to the microphone because I'm incredibly loud. It's even certified open source hardware. And the third one in Panama, apparently. A little bit of background on this project. You're going to talk about this bug thing, but why, Andy? Why? Well, let's all talk about this place. Does anybody know what this country is? There's clues. It's Panama. So Panama is this tiny little part that connects North and South America. It was easy to cut in half. Well, easier than other parts of the world if you're going to cut a continent in half. And so it's covered with amazing jungles. And there's this part that sticks out. It's called the Azuero Peninsula. And when the Americans, the people from the U.S. Specifically, were colonizing there, in World War II, they had thousands and thousands of troops, and those troops were like, we want hamburgers. And so they go, you know what? Let's chop down all this pesky, beautiful rainforest that's everywhere and have cows. And so this whole area, this whole peninsula, completely different climate caused directly by us within lifespans of people. There's even groups that find like 90-year-old people who go and tell other younger people about how, yes, we used to have monkeys. There used to be rainforest because it's dry. If you go there, when I first went there, I thought it was just a different biome in Panama. It's dry. It feels like California. It's brown. It's grassy. And it's not great for the local wildlife that used to live there. So what's the answer to this? Oh, boy, if you talk to tech people, just plant trees. Boy, I wish we could plant trees quicker. I'm going to have a drone maybe that puts trees in the ground. This is going to solve everything. This is one thing I want people to really know is we don't actually, as humans, know how to recreate healthy ecosystems. When we destroy stuff, we don't know how to recreate that at all. So people are like, I saw there used to be trees there. We chopped them down. It sucks now. Let's put trees back in. This creates these dead forests. 90% of all tree planting programs in the world, my friends did a survey on this, they're monocultures that plant non-native trees. None of the creatures actually want to live there. It's just a big tree farm that gets chopped down in 30 years to make teak furniture. So again, we don't yet know how to recreate healthy ecosystems. Luckily, there's people called scientists. Scientists really like to look at stuff and try to figure out like what's going on here. And so one thing that some scientists are doing is studying how we can reforest, how we can actually try to repair places in ways that actually make sense. One of the things that they do is they try to study biodiversity. Raise your hand if you've heard of biodiversity before. Cool. Okay, great. Biodiversity. The way it kind of works like this, gross simplification, you're like, oh, hey, we have untouched forests. We saw 98 monkeys there, 5 different species. We saw this place that we totally destroyed. No species of monkeys at all. And then we planted a couple trees there. Hey, one of the monkey species showed back up. Not as great as the original thing, not really comparable, but that's how we can kind of examine in a very broad way kind of the health of an ecosystem. And so there's really cool groups like Pro Eco Azuero and Pantera who are actually trying to replant these forests in healthy ways and are working with scientists to try to figure out what can we do to plant stuff in ways that make sense. But Andy, why are you looking at bugs? Why study moths? Well, when we think of biodiversity, and when you think of biodiversity probably, often people are like, yeah, man, that rainforest, there's like 50 species of birds, and there's like 8 different types of cool monkeys there. It's super hyper biodiverse. And mostly we think of birds and mammals when we think of biodiversity. And there's a lot more birds than there are mammals. So you're like, wow, so many cool birds there. But if you bring bugs in, it's mostly bugs. Insects are super hyper diverse. If we think about these terrestrial animals, 94% in this group is just bugs. Insects are super hyper diverse. And I really want to hit this into you because it blew my mind several times. If you think of everything since Western science started trying to give things names, like all plants, all animals, fungi, single-celled organisms, and we're like, yeah, okay, I found a new single-celled thing. I'm going to call it this Latin name, right? We've done that 2 million times, okay? There's 2 million things, and we keep finding more, but 2 million of those. Half of those are insects. It's nuts. 1 in every 2 species on Earth is an insect. 1 in every 5, again, all life is a beetle. 1 in every 13 is a moth. These things are super hyper diverse. Why do we care if they're hyper diverse? Because as tricky engineers and scientists, we want to use them as a sensor. And so compared to other things like mammals and birds, when we're thinking about this example, like, oh, hey, we replanted this forest and there used to be 5 and now there's 1. And it's like, okay, it gives me a rough measure. 5's more than 1. But when we start looking at bugs, we might be like, we saw 100,000 insects and 1,500, species of those. And now we planted some new things and these 206 showed up. You get way more granularity of your variables. Insects can be really hyper localized. Many species, especially in the tropics, like in Panama, where we have 16,000 species of moths and butterflies, some are actually even localized to very specific areas. Some caterpillars are even host specific, meaning that the plant that they eat is the only plant that they eat. So you actually even know about where that species is if you see this one particular type of caterpillar. Compare this to thinking about biodiversity monitoring with animals and camera traps, like how most of biodiversity monitoring happens right now. You might have a monkey. Very naively, you could look at this picture of the monkey and you're like, hey, I saw a picture of a monkey in a burned out field. Monkeys live in burned out fields. Okay. But we're not that naive. And so we realize this monkey's probably crossing this area, going to a place where it can actually survive better. And this range could be, tens of kilometers. Jaguars, can even be like hundreds of kilometers. Versus bugs, I might set up a moth box here, move it 100 meters away, get totally different kinds of things. Insects are also really easy to attract. Long ago, we figured out big bright light brings them in. We can look at them. Monkey did not show up when we had a big bright light. It's still really hard. The way that scientists do this is they have to have that big bright light. You have to get a couple like PhD folks, hang out there all night and look at all the bugs and figure out what all the bugs are. There's a lot of bugs. And this is one specific place, one specific night. So we thought, hey, there's got to be a better way. Some people published a paper in 2022 that was like, hey, let's use a little Raspberry Pi camera, automatically take pictures of bugs. And we're like, okay, let's do that. Let's buy something. Somebody else probably already made this. There's other groups out there who've made these things. Problem is, they're like 15K. They're about the size of a huge Pelican case. They're really heavy. And they have a pretty low resolution image. They just use like a Logitech webcam. It's like an 8 to 16 megapixel camera. So we're like, let's build our own. So we built and we built and we do lots of field testing. This is super duper important. Anything you make is going to fail when you bring it in the jungle or even just outside. The other thing, community testing. We put it in the hands of people who aren't us. If you're making something, do this over and over again. It's so painful because you put the button there that says like, press this button. The person never pushes that button. And so you learn like, oh, maybe I need to redesign my thing. But it's very super duper important if you want people to actually use these things. And importantly, it's designed in the field for the field. Because if you have digital technology, it's really wimpy. It likes hanging out in air-conditioned places where it doesn't rain and have an army ant raid go through. And so things work great in the lab. They totally fail in the field. So we tried to make everything repairable in the field. There's redundant parts. Everything can be put back together with like a hot glue stick, a lighter, and a razor. Redundant field parts. How does this thing actually work? I'll tell you more about it later. You basically just hang it on a tree. It turns on automatically. It uses the Raspberry Pi 5's integrated real-time clock. It turns on a big bright light, takes really high-resolution photos of it that you can look at on a little SD card. And then I have open scripts that run little open-source machine learning programs that we made that run locally. So even your old crappy laptop can churn through these in like 15 minutes. And then importantly, we made it so that you can actually refine IDs and have a human expert go through these collections and actually correct them. We're not going like, oh, we did AI, everything did perfectly. No, it's not great at thinking for you. What it's great at, it can organize stuff. It's a great pre-organizer. And so this is my friend Evan. Evan can go through an entire night's worth of bugs, like 3,000 bugs, in like 5-10 minutes. So it's great. All this data, if you're a scientist, you're like, yeah, cool, I got Darwin core stuff. I can send it to these databases where scientists do sciencey stuff with it. That's super great. You can also do weird stuff with it because it's fun. So you can make fun visualizations. I include all these scripts. You can make animations. You can even have like moths as like a cool lifestyle brand. So we have a fundraiser. You can buy these right now. You can buy moth fashion. This is data sets turned into fashion that you can check out right now. All the proceeds go to getting moth boxes to nice groups in Panama. And the specifications of this is where the thing really shines. We use this 64 megapixel camera, which is like, oh, that's cool. But then when you look at it, so we get all these bugs, right? Most other groups, they just like, okay, we look at the big bugs. We don't care about little bugs. Little bugs are important too. Everybody listen to this. So we can actually resolve down to species, millimeter size insects, which is bonkers. And it's also really important for when you want to determine like, okay, it's a moth, but like what type of moth? I want to see what kind of hairs. Does it have 5 reticulating hairs on its frontal scope? All kinds of stuff. The battery's cool. I got to shout out to Talent Cell. They make the cheapest, most compact battery that you can take on planes and people do not hassle you. And you can also plug solar panels into it. You can daisy chain these batteries. You can plug them into a wall outlet. You can really kind of abuse them. And I even went on the tour of their factory 2 weeks ago, and they're really nice. It's weatherproof. You can put different targets on it. One of the most important things is it's really small. And this is important because if you're going to bring something into thick, weird jungles, places where people don't really go, it can't be humongous. And so we've done deployments because it's so small all over the place. Panama, Peru, Ecuador, the US, Mexico, China. We've even done, this is me and Bree doing an amphibious deployment on some river in Panama. So we can set these things up everywhere. The biggest proof of concept, we did a whole mountain called Cerro Hoya. In one day, we set up 19 moth boxes and got all those places sampled independently. And this is huge. This is something humans couldn't do before because you would need like 19 PhDs hauling up their big light sheet and their light and just sitting there all night. And we did not have the funding to do that versus we can buy several of these. And you see really cool stuff. Again, this is simultaneous data. You can see the summit had a crazy amount of different insect sightings versus lower areas. And that's actually kind of troubling because when you're in the tropics and climate change happens, it gets warmer. Things that can't live where it's warmer go to higher elevations, which is great. They're just chilling. Problem is, once they get to the top of a mountain, they got nowhere to go. And so that's how species massively get extincted. Anyway, you can build your own. Everything's been designed for flat pack design, so you can laser cut it, 3D print it. People have made it. Scientists have made it. People have made it in Rhode Island. Eli, were you there building it with library kids? The future of Mothbox. We've done everything so far on less than about 100K, just getting little grants everywhere for the past 2 years. And that's what we see there is version 4. It's designed for basically off-the-shelf parts, put it together, start sampling now. But now scientists are really liking this thing and it's getting popular and they want like 20, 30, 50 at a time and we can't make that many. So now we're designing a new mass manufacturable one. And the American Museum of Natural History just gave us 20K. Wildlabs.net, a really cool forum. Join them. They have weird problems to solve. They gave us 50K to design a new PCB and do a bunch of tests over the next year. And so we're designing this version 5 and fully integrated one. Why am I at Open Hardware Summit? I need help. This is my first PCB I ever made, really, with KiCad. And so I taught myself some KiCad. I make some decisions. You'll see. And they're either genius or they're like, no, there's a reason people don't do that, Andy. And so this was a guy named Terry who told me some of those were reasons people don't do that. And so, for instance, like, look at that Raspberry Pi. It's like sideways. There's a hole going through. I don't know. Maybe it's cool. But anyway, so I'm Andy, and you can check more out about me. We have a mailing list. We send out mails like once a month about things like Dynacon and other cool events. There's also, if you want to know more about the Mothbox, and then you can hit us up on Blue Sky. We have a dead Instagram now because I just got sick of billionaire fascists. So anyway, hit me up. I got a moth shirt.